Well, hello, and welcome to my video lecture on query optimization, the last topic in Chapter 5. So query optimization brings together a lot of what we've been talking about as far as structure, as far as where to put the files and the file organization. So for instance, one of the first things we can do if we're in a multi-processor system, and again, most database management systems are installed on very powerful database servers that have whole bunch of RAM memory, whole bunch of disks, very fast disks. So we have a bunch of multiprocessors. So if we have multiprocessors, what we can do is, and first of all, what's a query? A query is a question that an external user poses to a database management system. So, give me all of the students that come from Hempstead, for instance, would be a query that I would pose to a database management system. So, in order to increase performance to get that information out to users, there are going to be multiple users querying multiple pieces of data in this database management system. So if it's possible to spread the load of all those different queries to the different processors, we can have what's known as parallel query processing, which is queries being processed across multiple processors. So that would be an optimization technique, tuning the database to tell it when it gets multiple queries to send those queries to be processed on different processors. We could have processors that are exclusively used simply for query processing. So if we have 100 processors in a server, we can say that maybe 40 of them are going to be associated with dealing with queries. We can also override any automatic query optimization. Most database management systems will, when you submit a query to them, will try to optimize that query themselves. So if we know our data and we write a query and we know that the automatic query optimization in the database management system is not going to be as efficient as a more direct way that we may know of, you can override that and make it use your optimization settings. We can also when you're picking the data block size, when you're saying, how big are my blocks? Am I doing random? Is it random access? Is it sequential row access? What are the row sizes? What's the speed of the accessing? All of those aspects can be tuned to make your queries return their data faster. And the other thing is balancing input-output across disk controllers. I mentioned this in a different video lecture, but if we have data that we have partitioned, and what we do is we call it striping across disks. So I have one table that's partitioned out amongst 50 different hard disks or secondary storage devices. That means I have 50 different disk controllers that can read the data for that table off of the disks at the same time. So if I had all of the data for that table on one disk, it would take 50 times longer than if I stripe that data across 50 different disks, because I have 50 different disk controllers reading the data at the same time. So all of those are different, various techniques to perform query optimization. There are a lot more than that. This isn't exactly the tip of the iceberg, but there are a lot more, but they get very, very sophisticated. I'm not going to cover them in this course because they are beyond the scope of this course. So that is the end of my video lecture on query optimization.